So this next page is just kind of a summary of everything that we just did. What types of functions are we going to be dealing with? Well, I showed you the library of functions, but they break into different categories. We're going to be talking about linears, quadratics, more so polynomials. Power functions are a type of polynomial. Root functions, which means radicals. Okay, reciprocal functions, in other words, fractions or rational functions, exponential functions, logarithmic functions. These are all the types of functions that we're going to be dealing with this semester in a calculus course. Again, with a traditional 220 calc, you're going to be dealing with trigonometric functions as well, but that's covered in a different packet. For brief calculus, these are the ones that I expect you to know. So what does a linear function look like? The key to a linear function is that you just have x to the first power. Quadratic functions, when you see the word quadratic, you should be thinking x squared. I'm also telling you your domain on all of these. What's a polynomial function? Polynomial function is just like a linear function or a quadratic function, except you can raise it to any power you want. So x, x squared, x cubed, x to the fourth. It does have to be a whole number, so something like x to the 1/2, where the power is a fraction. That is not a polynomial function. Polynomial functions are only functions where you have x's to the whole numbers, 1, 2, 3, 4, 5, etc. Power function, a power function is really just that leading term of a polynomial function. Root functions, those are your radicals. So remember, your root functions are your radicals. If it's an odd root, it's defined from -infinity to infinity. If it's an even root, it has to be greater than or equal to 0. You also have those reciprocal functions, which is a fraction. Remember, the reciprocal function's 1 over x. It's undefined when x equals 0. You have rational functions, which means, again, it's just a fraction. Rational means fraction here. Again, it's defined everywhere except for where the bottom's equal to 0. So to find that domain, you set the bottom equal to 0. You solve, you exclude those values. Exponential functions, we just looked at e to the x, but it doesn't have to be e. We can have any base as long as that base is between 0 and 1, so something like 1/2, or it's bigger than 1, so something like 2. So we don't have negative bases, and we don't have 1 as a base. Our domain is always -infinity to infinity. And the last type of function is those logarithmic functions. We just did the natural log of x, which is log base e of x. Again, our bases, because logarithms come from exponentials, they have to be between 0 and 1 or bigger than 1. Okay. The domain of every logarithmic function is 0 to infinity. Some values that you want to know so you can simplify is the natural log of e is 1 and the natural log of 1 is 0. And I also need you to know some of the logarithmic properties, because when we find derivatives this semester, using these logarithmic properties can take a very difficult problem and make it much, much simpler. So the logarithmic properties are, if there's multiplication on the inside, it separates to addition on the outside. If there's division on the inside, it separates to subtraction on the outside. Notice if it's addition or subtraction on the inside, that means nothing. You can't do anything with it. So you can only separate multiplication and separate division. Multiplication, addition, division turns into subtraction. Another thing that you can do with logarithms that you want to remember is if you have an exponent, so it's x to the r, you can bring that exponent down in front. It makes it much, much nicer to deal with that. So these are the 3 logarithmic rules that, yes, I don't have you doing too much with them in this packet, but I most certainly need you to memorize them because we will be using them later this semester within the next few weeks.